Okay, today we're looking at 7-2, which starts on 392, and we're looking at solving inequalities by using multiplication and division, which is very, very close to what we did yesterday. Solving inequalities using addition and subtraction. There you go. What's cool is that at the beginning, if you're looking on page 392, do you guys see that girl trying to lift up that rock? And actually, it is going to happen, and the reason it's going to happen is two things: math and science. Math and science. And what's awesome about it is this. You see that, and I can't go through that actual example, but you see that stick she's using? Okay, it's a certain length. It's a certain length, and it has to be of good durability. But that rock, can she normally pick up that rock and just move it out of the way? No. No, and the thing is, like, rocks, by the way, very dense, very heavy, and that rock is looks like half her size. I doubt it's going to happen. But with that stick, she can pry that rock out of its position and actually get it to move. The reason that's possible is because of that little diagram at the very top. Do you guys see where it's like a little balance beam? And you have a fulcrum, that little triangle. You have two sides of that stick, the resistance arm and the effort arm. Okay, based on that stick, so if I use this as a stick, based on where that fulcrum is, here, anywhere here, and the length of the resistance arm and the length of the effort arm, she can apply a certain amount of force and can make it move. So the thing is, the longer that effort arm is compared to that resistance arm has an effect on how much effort she has to put. Or you can think of it this way. You can multiply your strength by putting the fulcrum in the right position compared to the effort and the resistance. And so she puts all her effort, which normally does nothing to that rock, and as she puts all that effort, it multiplies her strength by 7 times. That's pretty cool. That's because of the stick and the fulcrum and all that, which you'll learn in physics more. Okay, so here what we're going to do is we're going to look at a simple inequality. 10 is less than 15. Would you agree with that? Okay, and I've done this last year, this kind of illustration, but maybe it's been a long time. This is a true statement, but what if I multiply both sides by 2? So I'm going to multiply both sides by 2, and I get 20 is less than 30. Is that true? All right, so that is a true statement. So when I multiplied both sides of this inequality by 2, did it keep it a true statement or true inequality? Yeah. All right, now what I'm going to do is I'm going to take the same inequality, and instead of multiplying it by 2, I'm going to multiply both sides by negative 2. So multiply by negative 2. Multiply. I'm clueless right now. So 10 times negative 2, negative 20. 15 times negative 2 is negative 30. Now, is negative 20 less than negative 30? Oh, that's actually a false statement. And don't forget, we're talking about two negatives. So negative 20 is not less than negative 30. But what can I do to this inequality? One thing I can do to change it back into a true inequality or a true statement. And this is something we've done, hopefully, a few times. Okay, you can multiply by negative 1, and then it would be a true statement. Or I can do this. I'm going to keep the negative 20 and the negative 30. Yeah, I'm going to change the direction of the inequality. So instead of less than, I'm going to say greater than. And that would now be true. Sorry, I don't have enough space to write that down. Yeah, new page now, so I have to go to a new page. You guys good with that? Yeah. Okay, when you multiply both sides by positive 2, did you change the truthfulness of the inequality? No. When you multiply both sides by negative 2, did you change the truthfulness of the inequality? Yes. We changed that it was not. We changed it from a true inequality to eventually a false one. Okay, well, let's keep going. 10 is less than 15. All right, I'm going to divide both sides by 5. Okay, so I'm going to divide both sides by 5. And that gets me 2 is less than 3. Is that true or false? That is true. That's not bad. So it's true. I'm going to take that same inequality, and this time I'm going to divide both sides by -5. -5. All right, so I get -2 is less than -3. Is that true? Oh, that is false. So in order to make it a true inequality, all I have to do is switch the direction of the inequality. So instead of -2 is less than -3, -2 is greater than -3. Do you guys remember what we did on these problems? When you multiply or divide, keyword, both sides by a negative number. Good question. What if you only multiply this side by negative or that side by negative, or division only on one side by a negative? It does not change that inequality. You got to do it to both sides. So all this to say, for this example, this is like the keynote of this lesson, and it's a long one. When multiplying, can I use cursive because it makes me look like I'm writing cursive anyway. So and my cursive is not great. So when multiplying or dividing, as you said that I messed up, dividing both sides of of an inequality. Yeah, see, my I's and my E's are not that great. By a negative number and I won't ever do this again. Yeah, thank you. You're welcome. Change the direction of the inequality sign. Yeah, I keep messing that up. Okay, I'll read it to you if you're like, what did you say? When multiplying or dividing both sides, that's super important, of an inequality by a negative number, change the direction of the inequality sign, okay? That's the whole point of this lesson. You work it out just like you did the other problems, but if you multiply or divide both sides, it has to be both sides by a negative number, then you change the direction. Okay, you guys good with that? That's the key to this lesson. If you get this, you're pretty set. Okay, example 2. I'm going to move from here. Example 2 we're going to go to. And we're looking at x divided by 12 is less than or equal to 3/2. Yeah, no more cursive. Especially with my numbers.
Yeah, I wondered if they were cursive.
They're not. I mean, you can make them more.
Squirrely.
Yes, swirly, whatever. Yeah, but I'm going to leave it like this. Okay, I want to solve for x. So what do I do to both sides? Okay, I'm going to multiply both sides by 12. Multiply both sides by 12. Because what happens with 12 times x divided by 12? Well, the 12s cancel each other out, don't they? So I'm left with x is less than or equal to 18. If you do this math, good? Okay, did I change the direction of the inequality? Why not? Yes, I did not multiply both sides by a negative. I keep it there. But we want to write this in set builder. So set builder. So what do you have to add to this, which is really not that bad, I hope. Set builder. Josh?
Is that x is...
Any number.
Oh, yeah, any number such that x is
X is any number such that X is less than or equal to 18. That is the correct answer. And another thing, on this lesson, you do not have to graph. So as you did on the previous lesson, you did have to graph it. And I'm just trying to hold off that clapping. And I'm doing okay on that. Okay, that's your answer. That's your answer.
Great job, Mr. Ed. Great job.
All right, let's go to example 3. Another example here. Negative 3w is less than 27. All right, I want to solve for w, so what do I do? Yes, sir. Okay, I'm going to divide both sides by negative 3. All right, so here I get w, and here I get negative 9. And since we divided both sides by negative, then we change it from greater than to less than. It gets changed. All right, and then what is my correct answer in set builder notation? Margot?
W line, W.
W line, is that what you mean?
Yes.
W line. So can anyone read that for me? What does it mean by W line W? Walker?
W is any number such that W is less than negative 9.
Good. W is any number such that W is less than negative 9. But as I look at that answer, I'm thinking to myself, is that really even true? Like, I know we did the work right, but is that really the solution? So think of it here. Give me a number, and let's just go with a whole number, that is less than negative 9. Less than negative 9. Ellie, I see that hand. Less than negative 9.
Negative 10.
Okay, negative 10. So should that be a part of my solution?
Yes.
Should be. So here's the original inequality. What's negative 3 times negative 10?
30.
Positive 30 is greater than 27? Yes. Now, if you were to graph it, okay, I'm not saying you have to, would you have an open or closed circle on negative 9? Open, right? It doesn't include negative 9. So should negative 9 be a solution? All right, let's check it out. What's negative 3 times negative 9? 27. Is 27 greater than 27? No. Give me a number that should not fit in this inequality. Another number that should not fit. So what is not greater than negative 9? Negative 8. What's negative 3 times negative 8? 24 is greater than 27? No. This is my solution. And it can be checked. So you see that mental check you're doing? Thinking of the number line, thinking of greater than, less than. All right, you guys are doing so. I'm going to hold off on that problem. Go to page 396, and we're going to do some verbal exercises here. Yeah. 396. Look at the very top, 9 through 12. This is what I want us to do all together. We're going to do this all together. It says, state the number by which you multiply or divide to solve each inequality. Indicate whether the direction of the inequality symbol reverses. That's all we're going to do. We're not going to solve them. All right, so number 9. This is what you would tell me. What do you have to multiply or divide both sides by? So tell me the number. Josh?
Negative 27.
Number 9.
Negative 6.
Okay, would you agree that you would have to divide both sides by negative 6? So you guys would say divide by negative 6. Does that sound good? Now, the second question is this. When you divide by negative 6, does it change the direction of the inequality?
Yes.
So you would say yes. Okay, so divide by negative 6, and then yes. Okay, ready? Number 10. What do you do here? Everybody, divide by 10. Does that change it? No, because you're dividing by a positive. Number 11. What do you do to both sides? Multiply by 4. Does it change the direction? No. 12. Okay, two ways to work this one out. You guys gave me both of them. On number 12, you guys, some of you said, divide both sides by -2/7. That's correct. Would that change the direction of the sign? Yes. Some of you, though, were thinking, wait, can't you multiply by -7/2? The reciprocal? And that would change the sign? It still changes the sign. Okay, and you're like, what just happened? Let's look at number 13. We're actually going to work this one out. Number 13. All right, this one is 4/5 x is less than 24. Okay, there are two ways to solve this. What's one way to do it? One way to do it. It's not the only way, it's one way. Hayes? Okay, I'm going to multiply by the reciprocal of 4/5. Why would I do that? Like, why is that? I mean, why don't I just divide by 4/5? That seems easier to me. Really? Like, okay, let me write this down here.
Yes.
That?
Yes.
And then I'm going to do it over here, I guess. Oh, because what's a number times its reciprocal always? 1. So that basically does that. And you're left with x. And then what am I left with here? Yeah, because the 4 and the 24 cancel. 6 and 1. Then I get my less than 30. Okay, so that's what I did on that work. Is that the correct answer?
No.
What?
No.
Oh, what's wrong with it?
That's stronger.
X is any number such that x is less than 30. Okay, so that's your complete answer. So get used to Set Builder. You'll do it more and more, and then it won't even be a problem. You guys okay with that? How many of you feel very comfortable with this? Good. So do number 14, and you will get your assignment after that. As you guys are working it out, I'm in a dilemma. I would love to work this problem out, but I'm thinking of it in two ways. Which way is correct?
They're both correct.
Wait. One of them has v being positive, negative. Oh, negative, positive. You can't do that. Okay, do you guys remember with your slope? Do you remember how I can let you do that? You can make the negative go up top or down low. How many of you worked it out with the 3 being negative? How many of you worked it out with the v being negative, which is probably the least common? Okay, let's work it out this way. Sorry about that. So here, what do you have to do to solve for v? Okay, multiply both sides by -3. Okay, I get v, and I get -12, and less than or equal to, and v is any number such that v is less than or equal to -12. All right, great. But if you worked it out the other way, I'm sorry, it would not work out the same as the first. So I'm looking at this and thinking, what do you do to both sides? Multiply by 3. Ha! You get -v is greater than 12.
But then you want to switch the v.
Oh, do we want to solve for -v or positive v? So what do I do to both sides now? You can either multiply both sides by -1 or divide both sides by -1. So I get v and -12. And then what? And then you get your v is any number such that v. All right, same answer, right? So either way you took it, you get the same answer. But do you guys understand that the v could be negative, or sorry, v positive? Wow. Okay, your homework is not that bad. Let me give it to you right now. It's 21 to 43 odd. Wow. And actually, you still have like 2 minutes, so because that bell's still off. 396 to 397. But hold on. 21 to 43 odd And then just number 51. So write that down at least. Sorry about that time.